the magnitude, we are finding the formula and satisfy how to get the formula of magnitude of the second order transfer function of frequency response. Okay, so our magnitude m is equal to 1 upon radical 1 minus x square into whole square plus 2 zeta. This is our zeta, which is our damping constant basically, and which is multiplied by the x, and this is our the normalized frequency, and we are taking the whole square. So now our x is a normalized frequency which is equal to omega 1 upon omega n. Now for the bandwidth, we are taking the condition as m is greater than 1 upon radical 2. So here I am taking the 1 upon radical 2 equal to this equation. So 1 upon radical 1 minus x square into the whole square plus 2 zeta x into whole square. Now we can simplify furthermore it. So we're getting it 2 equal to 1 minus x square into whole square plus 2 zeta x square. Now I'm simply square it. So I'm getting then 1 minus 2 into x square plus 4 square. Then 2 simply that I also squared that, then I'm getting 4 zeta x square into x square. Now further simplify that equation. So x square plus 4 zeta minus 2 x square, here x square term and also here the x square term, so I'm taking the common here. So for zeta minus 2 is outer, we are taking the x square because here I'm taking the common. So here minus 1 because it's changed its side. Now it considered as a, it considered as a b, and it considered as a c. Now we are applying the quadratic equation on it to further simplify it. So x square equal to minus a, we also you very well know about the quadratic equation. So simply here I am putting the equal values of these. Now the x square equal to minus b is our 4 zeta minus 2 plus minus, and b is 4 zeta minus 2 whole square minus 4, a over is 1 and c is also a 1, and 2 into 1 because our a is here 1. Now further we are simplifying it, so we getting x square equal to 1 minus 2 zeta square plus minus 2 radical 2 zeta square minus 1 into whole square plus 1. Now the x only we are consider here the word plus minus, but in this case I'm taking the positive sign. So the x square equals to 1 minus 2 into zeta square plus radical 4 zeta 4 minus 4 zeta square plus 2. Now our x becomes radical 1 minus 2 zeta square plus radical 4 zeta 4 minus 4 zeta 4 plus 2. Now here, as I told you, I am taking the x equal to omega upon n and considering this case basically, which is m is also greater than 1 upon radical 2. So I'm putting the omega b upon omega n at the side of the x, which is equals to now radical 1 minus 2 zeta square plus radical 4 zeta 4 minus 4 zeta 4 plus 2. Now this n become multiply with this because it is in denominator. So the omega b equal to omega n radical minus 2 zeta 2 radical plus radical 4 zeta 4 minus zeta 4 plus 1. This is our the basically actual formula of the bandwidth of the second order system in the frequency response. Now here I'm taking the example to define furthermore it the frequency response. Basically there is our amplitude which is from the which is 1, and at the following age it is the range of 0.70, and this is the pretty range of from 0 to omega w, which is our bandwidth. This is our initial condition basically, and it is the amplitude is the maximum amplitude is 1.